Can you hear me? Yep. All right, great. So welcome to RF channel number 3. So that means you can all hear me. All right, so we're going to start. Can I have the presentation, please? All right, my name is Lalit Kumar. I'm Solution Architect with Amazon Web Services. I'll start with a quote. Friends don't let friends store data unencrypted. Why? Because encryption is one of the most powerful control that is being built to secure data. You can store and process data securely with encryption. But while encrypting, it should be easy. It should not be very difficult. It should not be understanding all the complexities and maths behind the algorithm of encryption. It should be easy to implement for a developer, for any organization. We have specifically built 2 services around encryption. First one is AWS Key Management Service that stores the keys which are used to encrypt your data. The second is AWS Certificate Manager, using which you can deploy SSL certificate securely for your application. We are going to refer to these services during the course of presentation as KMS and ACM. Now, the first one is Key Management Service. How do you encrypt the data? You have your data, and there is an encryption algorithm. That means there is some maths there, and then there is a key. The key need to be applied, or the algorithm need to be applied to the data, and you get encrypted data. The key need to be stored somewhere, and that's where the KMS comes into picture. Typically what you have is data and information. Data and information need to be secured. How do you secure that? You have an encryption key which is called the data key, which will be used to encrypt your data. But what about the key itself? We can't store that key in plain text, because if you have that on plain text, that means anyone can get that and actually can decrypt the data. So the key further need to be secured. The data key will be encrypted again by something called a master key, which is stored onto the KMS service, on the key management service. The master key never leaves KMS. The KMS behind the scene runs on a hardware security module, which is FIPS 142-2 compliant, to meet your regulatory workloads, to meet the compliance. So what we end up with, encrypted data and encrypted data key. The certificate manager. What we have users and customers who are interacting with our application. They interact at the boundary. The boundary is where we have CloudFront, where we have Elastic Load Balancer, or the API gateway. These are the entry points for any application that you're running on AWS. So they connect in the back end to your AWS environment. So the landing zone is at the border, which is CloudFront, Elastic Load Balancer, or API gateway. ACM securely deploy SSL certificate on CloudFront, ELB, and API gateway. And the private key, the certificates are also encrypted again by KMS in the background. Again, it's been encrypted by a master key which never leaves the KMS. But let's look from your workload perspective, how your workload will look like. Your workload could be a multi-tier application where you might be using various services, and you have to ensure the data at rest as well as data in transit need to be secured and need your compliance requirement. Your workload might be something like this. You store data on S3. Static content goes on S3. Maybe the website static content, but apart from that, you also store sensitive information in the form of backup, in the form of maybe just capturing data, customer data onto S3 bucket. Other area where data reside is the application where your customers are connecting to, where customers are interacting with. That data resides on EBS volume, which is connected to EC2. And the third one is, of course, you're writing the data to a database, which could be a RDS. So these are the areas where data is stored. What about the network? From a network perspective, we talked about S3, EBS, RDS. What about the network? During transit, when the user connect to your edge, that means to a CloudFront or to ELB, that communication need to be secure as well. So the communication between user, CloudFront, and CloudFront to ELB also need to be secured. That's how your typical multi-tier application architecture will look like. So we need to make sure all these areas, whether it's in transit or at rest, we have to secure the data. How do you protect data in S3? As this talk is about KMS and encryption and ACM, you write content onto S3, either the user access the S3 bucket or an application read and write through an S3 bucket. Right in the bucket properties, there's an option right there which you can choose, which is either a server-side encryption or a KMS-backed encryption. That means you have to pre-provision KMS keys, and behind the scene AES encryption is being applied. All the content in your bucket would now be secure. You provide the KMS key and we encrypt whatever you write, the objects you write to the bucket. And for decryption, of course, it need to call the key. The data key is being decrypted by the master key, which it gets by calling the KMS. So no very complex configuration right from the console. It's just a radio button. You just click that and it does the encryption for you. But a developer might work on a command line or an API. So it's a simple flag that could be set for our S3 bucket. Now, apart from just encrypting the data, it's also important what kind of permissions we are putting in. So KMS does integrate with IAM, where you can have granular control and define who can actually encrypt or decrypt the data, who has the permission to call KMS. Consider this. There's an EC2 which is running the application, and that application requires permission to encrypt and decrypt the data. If anybody else, any other application or any user will try to access the data, they will not get the data in plain text. So you define permission for the keys. You define an IAM role. For the EC2 IAM roles, you don't have to put any kind of access key and secret key. IAM roles are for automated access between services. So if you are running an application on EC2, you add an IAM role to access S3. Now what if your bucket policies has been modified, let's say by accident, you make it public. If your bucket has been made public, that means anyone can read and write from it. But if KMS has been applied it's still not readable because it still requires permission. So your read and write are being denied. Why? Because it requires KMS key permission. The users who are connecting or any other application, they does not have IAM role which has a permission to talk to KMS to get the master key to decrypt the data key. So that does not exist, and hence your data in S3 is still secure. Use KMS and never risk exposing your data outside. Other aspect is EC2 and EBS volume. On the EBS volume side, let's understand how it works. There is a compute layer, which is EC2, and there is a EBS volume. EBS volume is a storage layer which connects to a server. That means you mount the disk to the server where a file system is being written based on Linux or Windows. How do you do encryption? In the past, encryption, you have to supply the plain text key and you encrypt the entire volume. The process was painful. You have to enter the passphrase manually. Do we recommend doing this? No, we don't recommend this. But what we provide, the mechanism that we provide is an integration encryption service right from the console when you're provisioning an EBS volume. So when you provision an EC2 volume, you also attach an EBS volume. At that point of time, right there, you have an option of defining whether you want encryption or not. And define the key, choose the key which you want, and your entire volume will be encrypted. What all would be encrypted? The underlying EBS volume, whatever is being written there, and the communication between the EC2 and EBS volume will also be encrypted. So data moving is also encrypted. What about the server which is running application itself? Underlying server performs the encryption, decryption. That means it's go and talk to KMS service, which is again governed by IAM policy. So you have your storage layer encrypted. Now, the snapshot which has been created, one of the method to exfiltrate data is you have a volume, somebody created a snapshot out of it and attached it to a different machine and extracted the data. That could be a mechanism, but if your EBS volumes are encrypted, the snapshots will also be encrypted. That means they could not decrypt that snapshot. If they create a volume, that volume is also encrypted, and for decryption it still requires the same key and the permissions. So all EBS volume that are created as encrypted volume will have encrypted snapshot. The same paradigm, that means the KMS is applied, or the encryption is applied and the key is stored in the KMS, then you don't have a risk of exposing your backup to the world. Not just the EBS volume and the EC2 instance, the same paradigm is applicable to RDS. Behind the scene, RDS is a managed database service running on top of EC2 and leveraging EBS volume. If you encrypt the EBS volume for the RDS, that means right from the console, in RDS you have a choice to encrypt it. It's just a simple flag or a check mark. So you could also encrypt your database. Now certain databases have native encryption capability like transparent data encryption. What if it's a MySQL kind of database? What if it's Postgres or MariaDB which does not have a native capability? At that point of time you can leverage either the application logic which you have to write, you have to spend time on that, or leverage the feature of native encryption from AWS where you choose to encrypt the RDS database and will encrypt the entire volume for you. Now, where do you share your data? You have a complete control in which region you move your data around, and also with which account you share your data. You might have multiple accounts in your organization and you want to share certain data. You want to share certain volume or backup. You define the permission for that, and you define permission for KMS to use it. So at all the point, you have a complete control over where your data move. What if you are running serverless? You don't use EC2 and you're running completely serverless. If you're using Lambda, even with Lambda, you have something called environment variables. You can actually encrypt your environment variables, and you can decrypt environment variables. Behind the scene, it integrates with KMS. You can also define data encryption at rest as well as in transit. While using Lambda, which is a serverless compute paradigm, you don't need to manage any kind of server. You just have to upload your code, and basis on an event, we will execute that code. Since there's no EBS volume attached here, you still require certain security so that you don't expose your environment variable. That could be done with KMS. So KMS also integrates with Lambda. So this is our multi-tier workload, and we have to make sure that every block is encrypted and we have security everywhere. With KMS and encryption, which is integrated, I can encrypt the bucket, I can encrypt EBS volume, I could also encrypt my databases. But we didn't talk about other things. What all you share on a network? Maybe your login ID, maybe your payment details, your password, your personal information, confidential data, sensitive data. While this data is at rest, it's secure because of the encryption. But while in transit, it also needs to be made secure, for which TLS or SSL certificates are used. So now we'll look for protecting data in transit. How do we protect data while data is in motion, while data is in transit? Now, why we need it? We don't want anyone listening on the network. We don't want any eavesdropper. So the typical problem of eavesdropping is being solved by SSL. So, as we say, dance like no one is watching and encrypt like everyone is. How do you request a certificate? Amazon provides something called Amazon Certificate Manager, which we call ACM. For your domains, for your workloads, which are using CloudFront, API Gateway, or Elastic Load Balancer, you could request for SSL. That means you don't have to buy a certificate from outside. ACM provides you certificate. And how do you add it to your domain? You could have a domain validation or an email validation method. And ACM will securely deploy SSL certificate for your workload. So there's an automated, ACM provides automated certificate renewal. Can you also import certificate which you have taken outside Amazon? Yes. You could also import certificates which you have already taken from outside, and we'll manage the life cycle of those certificates. While we could not deploy a certificate outside Amazon, we still manage the life cycle of those certificates. So there's automated renewal and automated deployment on Amazon. How does it work? How does ACM work? Behind the scene, ACM utilizes KMS, and where it gets deployed on CloudFront, Elastic Load Balancer, and API Gateway. There are other integrated services like Elastic Beanstalk or CloudFormation Template. CloudFormation Template is infrastructure as a code. When you're deploying your infrastructure, you could define ACM hooks and you deploy the certificate automatically on ELB. So security is our top priority. What we are doing in this, see, implementation of OpenSSL is quite tricky because there's 10,000 lines of code. What apart from ACM we have done is we have also have something called S2N. S2N is an open source package which we have developed for TLS, where we have actually eliminated or we are not using the rarely used features. We have turned them off, and the code is reduced to 6,000 lines. That means less amount of code to deploy TLS. So look at GitHub for S2N, and you can have a better TLS or much faster TLS implementation and performant. So the certificate and private key for SSL are encrypted with the data key, and the master key, which encrypts the data key, resides on KMS. So the data key is reside on KMS. That means the same control regulatory requirement of PCI DSS, of HIPAA, of other FedRAMP, SOC are still applied to ACM. Since we have multi-tier workload, we have seen how the data is secured at rest. For data in transit, we do have ACM, which deploys SSL certificates. So the entire architecture could be secured with encryption. Now it's also very important how we have auditability. How do we have visibility? How do we have control? Whether whatever we talked about, is it really working, and how can I see it in action? How do I track what's happening? How do I track actions? How do we record what has happened? How do we know that it's really working? So we need some kind of control and visibility for that. The KMS gets service requests from various services, that means various application users and the API request. All the actions are being recorded in CloudTrail. CloudTrail is our audit service on AWS platform. Any API call, that means any action on the management console, or any action taken by an API call, any action taken by any SDK, any application, that is being recorded in CloudTrail. And of course, it's been stored on S3 for durability, so that at a later point of time, you can come in and actually look at the logs. CloudTrail provides API logs for your account per region. Its ability to detect missing and alter logs. If your logs are missing, it can also notify you. So what CloudTrail solves for us is looking at the logs, all the API logs. It also supports filtering rules. That means you can quickly reach by a timestamp, you can filter it out, or by a service you can filter out, by a user you can filter it out. Essentially, it solves 6 Ws. What happened? When did it happen? Which action in service? Where to? Who did it? And where from? So these are the 6 W that we solve with control and visibility with CloudTrail logs. Let's look at an example. How does the log look like? So this is an example of a CloudTrail logs, which is written in a JSON format. That means I can easily parse the log. Rather than a text, JSON would be much friendlier to parse the logs. Let's see what happened. There is an error code, access denied. That means someone tried to access the service and the access has been denied. But when did it happen? What's the timestamp? So we know the event time. This happened at this particular time. Which action was taken by the service? It tried to decrypt. So someone is trying to decrypt data which is stored in S3 bucket, but then access has been denied. So this is an event which I need to be aware of to know who's trying to decrypt my data. Then where to? Who? It happened in Sydney region. AP Southeast -2. Which region it happened, whether it happened in Mumbai, in US region or Singapore region, I need to know where it happened. And where from, where exactly the call has originated. Is it from outside Amazon or it's Amazon internal service? I might be running an application which is trying to decrypt the data, but it does not have permission. And who did it? So this is the role we have defined. That means I need to check the permission being given to this web app. The AWS platform provides global compliance. So by default, all our region goes through a lot of compliance program. Every 6 months, this is being validated. Some of the examples are SOC 1, SOC 2, SOC 3, FedRAMP, PCI DSS, which is running your credit card, healthcare industry, HIPAA compliance, NIST, CSA, FedRAMP, and specifically to encryption, there is a FIPS 140-2 compliance. That means the control of the KMS is being established in SOC reports, and FIPS 140-2 establish that there is no mechanism by which the master key could be taken out. So there's no tooling built in KMS where somebody can or an individual can take out the master key in a plain text. It does not provide any tooling. That's a validation being done by FIPS 140-2. So if you're running any kind of financial workload, healthcare workload, where you need to encrypt the data, maybe you're storing credit card information, maybe you're storing patient information, PII data, you could leverage KMS to encrypt that workload. Specific to KMS, it complies with the ISO framework. It also complies with PCI DSS, the payment workloads, HIPAA, healthcare workload, FedRAMP, which is the US government, and SOC 1, SOC 2, SOC 3 workload. Now, KMS, some of the use cases. KMS, as we have seen, is used to encrypt the data at rest. Now, if you're building any application which requires encryption, you could simply choose at the EBS layer, at the S3 layer, or at the database layer, whether you want to encrypt that or not. Now, there are some interesting use cases of KMS. What if you have to store or build your own secret management system? With S3 and KMS, you could actually build your own secret management system. That means you could build a vault kind of service. Let's say you're writing certain secrets on S3, and your application requires those secrets. Those secrets could be maybe the database credential. So that could be a database credential that you want, but you don't want in a plain text written in a config.js file. So every time your application, whenever it requires it, will go and fetch the information of the master key, and that will decrypt the data key, that will decrypt your data and give your data in a plain text. So you could think of various use cases apart from just the industry regulated workloads. We have also built something on top of it called Secret Manager, where you can store database credential or a parameter store, which is typically useful in a container kind of environment. If you're running Dockers, you're running container, you want to store your secrets into a parameter store, so which is being given by EC2SSM, which behind the scene uses the same KMS. So KMS complies to all these governance programs. So what we learn, that encryption, it's not difficult. All you have to do is choose the right option. You have to just select that you want to encrypt a particular data, create a key for it, and you have a guarantee by the compliance certification that your master key will never be compromised. That means your data is secure. Second, it does integrate with broad range of services, whether S3, EBS, RDS, Lambda, Redshift. It integrates with almost 34 services. And there is a strong control and visibility of your data. You can actually know what has been compromised or what access has been, what error is there if somebody tried to decrypt the data without permission. How much does it cost? That's a question that everyone have. How much this entire encryption thing cost for me? It's easy to use, but what is the cost of it? ACM, the cost of deploying SSL certificate and the certificate itself is 0. That means on ELB, API Gateway, CloudFront, you can deploy your SSL certificate from ACM and manage their lifecycle as well without any cost. The key management service, what's the cost here? It's $1 per customer managed master key. So you have a customer managed key. Now, one thing I want to mention here is when you deploy a particular service, let's say you use S3 or you use Lambda or you use an EC2, behind the scene, we also deploy a master key for you so that in case you want to use encryption. But you could also bring in your secret material, your key material. That means from your on-premise system, you can also import keys within KMS, and you can store your keys within KMS. And the lifecycle rotation will be entirely managed. You can just choose to rotate the keys. So $1 per master key, and then there is like a 3 cents per 10,000 calls. There is a generous free tier as well, up to 20,000. It comes under free tier request. So in a very inexpensive way, you could run encryption, you could use encryption and secure your data. How do you start now? You have to start from somewhere. How do you start? The very first thing that you do is you enable CloudTrail log. First of all, you need to have a visibility what is going on in your account. So enable CloudTrail log, not just for encryption, for everything else. You want to have an audit trail, who did what all API calls are there, so you can filter out the logs and see what's happening in your account. So it gives you a great visibility. Store it in S3 for durability. And then enable encryption at rest at least. At rest, it's a simple checkbox. If you're using console, if you're using command line, it's just one flag. There are 34 services which are integrated with KMS. Whether these are storage services, maybe Glacier, maybe storage gateway, maybe EBS, EFS, S3, analytics service. While you're storing the data, I took example of Lambda, which is completely serverless. Lambda might store the data into DynamoDB. After the processing layer, which is Lambda, it stores the data somewhere for persistence. That means it needs to write to a database, and you can also encrypt DynamoDB with KMS. So it also integrates with DynamoDB. It also integrates with your Redshift if you are doing data warehousing. For developers, you could also encrypt your artifacts which you are developing. You can also encrypt your artifacts and make sure your IP get never leaked. Then streaming services while your data is in stream. One of the trend is now AI is picking up and everyone is talking about machine learning. The models that you're building, they're also your assets. You have built those models, you have used algorithm, you have trained them. You could also encrypt your models with KMS, so it's also integrate with SageMaker. Other services like messaging, Connect, CloudTrail, CloudWatch, and of course ACM integrates with KMS. These are the reference guides. You could look at them. You could take a picture or you can scan the QR code. I'll pause for a minute here. There are 3 guides here. One talks about Amazon S3. How do you encrypt your bucket? Most probably the first starting point for someone is storing data in S3. So you could go ahead and see how you could encrypt your data in S3. Second one is a developer guide, how a developer would use KMS API. So we also have SDK for KMS. That also means that KMS could also be used to encrypt or to store the master key for the data that you're going to use or encrypt in your on-premise system. Then of course there is a security blog where we have a lot of implementation details around KMS and how various services utilizes KMS. So it's very easy to get started with KMS, a simple option of checkbox or a flag in command line. Thank you and stay secure.